All right, we are on page 4 of the Unit 10 packet, and hopefully you did 17 and 19 and then added 18 and 20 to your blue book, but I'll show you exactly what those look like. We're basically going to do 21 right now together, but I'm also going to go through what 17 and 19 should have looked like. I guess hopefully things went okay. You were supposed to just click next on the our applet, and then it should have shown you what was going on. So the point of what you just did, let's talk about what the point was. So if I have a circle, okay, so I have a circle. Now, we're not talking about angles anymore. That's all we've been dealing with are angles. So we're going to now talk about segment lengths. So in any circle, if I have any two chords, they don't have to be diameters, just any two chords, no matter what the chords are, if the two chords intersect, then this piece, the two pieces of the first chord, so A times B, will equal the two pieces of the second chord, so C times D. We call this the chord problem. And the way that I remember this is that if I have a chord, I just think part times part equals part times part. So let's do an example. Let's say that we have this circle. We have these two chords intersecting. And if I told you that this one was A and this was 6, and this guy was, we'll go with 9 and 3. Then we would take the two parts of the first one and multiply them, 6A. The two parts of the second one, multiply them, 3 times 9. So I get 6A equals 27. I would divide by 6. And if I divide 27 by 6, I know 6 goes into 27 4 times with 3 left over, so it would be 4.5. So A in this case would equal 4.5. There are going to be some more for you to practice on your homework, but we're going to go to the next case. All right, the next case also has a circle, but this time instead of having two chords in the circle, we have two secant segments. Now we know that secants actually extend on forever in both directions, but I'm just going to draw them as segments in this case because it's just going to be way easier to look at them that way. And if you went through the applet, this is a secant problem. And if you went through the applet, hopefully you noticed that this outside piece right here times this whole secant segment, which we'll call B, equals this outside piece times its whole secant segment. So again, it's AB equals CD. And again, I want you to realize that it's the whole secant times its outside piece. And that's the most common mistake people will make with this. So I think of this as the whole secant times its outside piece equals the whole secant times its outside piece. So the way I remember this one is I say sec out equals sec out. So let's go ahead and do an example of that one. So if I would have two secants, and I know the outside piece of the top one is 3, the inside piece is 6, the outside piece of the bottom one is 4, and I want to find the inside piece here, I will have to set it up, and there's going to be a little more algebra involved in this one. Because this says sec out equals sec out. So it is not 3 times 6. Instead, what is the whole secant? Well, the whole secant there is 9. So it's secant times its outside piece, which happens to be 3. Then we have this whole secant, which would be 4 plus whatever x is. So that's the whole secant times its outside piece, which happens to be 4. So this time I'm going to have 27 equals, and if I go ahead and distribute this, I'm going to get 16 plus 4x. I'm going to subtract 16 from both sides, which is 11. And then I'm going to divide by 4. So x will equal 2 3/4 this time. I'm really striking out for coming up with ones that come out even, so sorry, but hopefully you can follow the process. All right, we have a third case here, so we're going to go to that one next. Our third case is when I have a circle and I have one secant and a tangent. All right, for this one you did not do an applet on. This would go with number 21, but I'm actually not going to ask you guys to prove it. We're just going to go through it. So this one works similarly with the secant. So this is a secant tangent problem. So we have a secant tangent. It's the same idea that it's the whole secant times its outside piece. So it would be A times B again. And that's sec times out. But this time there's only one piece for the tangent. We have to multiply two things together, so we're just going to call that C, and we're going to take it times itself. So in other words, it's the tangent squared. So sec out equals tan squared. And this is our last case. So let's go ahead and take a look at an example of it. So if I have a secant and any tangent, I'm going to say that this is 4 and this is 6. And I'm going to ask, what is the tangent? Well, again, it's sec, so the whole thing, times the outside, times 4, equals tangent squared. So that would be 40 equals x squared. And I know if I square root both sides, I know that this would be 4 times 10. And I can bring out the 4 as a 2. So 2 square roots of 10 equals x. So that would be our x. All right, I'm going to ask you guys to go ahead and go now to page 6. And if you would try the first 3 and then come back and check them. I will walk you through what all 3 of them should look like, and then we'll try the next 3 and so on. Your homework is going to be to go ahead and finish all of number 23. So I'd like you to give those your best go. But I'm going to have all the answers and the way to do them on here. Just try them first before you check. All right, so go ahead and try A, B, and C, and then we'll check them. All right, so the first thing I ask myself when I do these is I say, what do I have? Do I have part? Do I have chord? Do I have secant, or do I have secant, tangent? And in this one, I have chord. So I know that my rule is these two pieces, so 14x, will equal these two pieces multiplied together, so 7 times 8. And that happens to be 56 on the right and 14x. And if I divide by 14, I find out that x equals 4. All right, going to the next problem. This one is a secant tangent. So I know it's sec out equals tan squared. And again, the most common mistake is people won't do the whole secant. So 24 plus 8 is the secant times its outside piece is 8 equals the tangent squared. Well, I know 24 plus 8 is 32, so this is 32. And if I take that times 8, I get 256 equals x squared, and the square root of that happens to be 16. So this answer is 16, and this one was 4. All right, and then we have our last type of problem here, which happens, or no, it's the same type, I'm sorry, it's a secant and a tangent. So it'll be the whole secant, which is 4 plus x, times its outside piece, which is 4, equals the tangent squared. So this would be 16 plus 4x will equal 64. If I go ahead and subtract 16 from both sides, I get 48. And if I divide both sides by 4, I get 12. So x equals 12. I hope those 3 went well for you. All right, I'm actually not going to do the rest of these on the video. Instead, I've left the answer key for the rest of them just on paper. So you guys can check and see how I did that, and I'm happy to help you if you have any questions. Come on in tomorrow. Page number 6 and number 23, all 9 of those problems I want done when you come in tomorrow. All right, have a great day.